Good afternoon. This is Galen Barbos from Lawrence Berkeley National Lab. Welcome to today's webinar, where we will be presenting the findings from a report that was issued just this last week, and that seeks to analyze characteristics of low-priced solar photovoltaic systems in the United States. This report is one in an ongoing series of papers that all involve collaborations between researchers at Berkeley Lab and at a number of academic institutions. And really the common thread among all of the papers in this series is that they all seek to explore dynamics related to PV system pricing and markets, and to do so using large data sets and relatively sophisticated statistical techniques. Some of you may be familiar with the Tracking the Sun annual report that Berkeley Lab puts out each year, and that tracks historical trends in the price of PV in the U.S. This paper, like many of the others in the series, draws upon that data set and really attempts to kind of dive more deeply into some of the trends that we see in those data. So this most recent paper was led by Greg Nemeth from the University of Wisconsin, and also involved contributions from the many other folks listed on the slide here. I'm going to hand the mic over to Greg in a moment, who will then lead us through the material. We'll also hear from Ryan Weiser, who will talk a little bit about the broader set of papers in this series. And then we'll have about maybe 15 or 20 minutes at the end for Q&A. Before getting started, I want to just go over a few quick housekeeping items. First is that this webinar is being recorded, and both the recording and the slides themselves will be available for download afterwards, and we'll provide the web address at the end of the presentation where you can download those items, as well as the report itself and a short fact sheet. Second item here is that you all are in listen-only mode, and so you can submit your questions for the Q&A portion via the chat window in the bottom left-hand pane on your computer. And we'd encourage you to submit those questions just as we go. I'll be kind of standing by in the background, compiling these questions and queuing them up. And it's always easier to do that if we've kind of got the list assembled before we get to the Q&A, rather than doing it in real time. That being said, of course, feel free to ask questions then as well. So with that, Greg, why don't you take it away?
Thanks, Galen. Yeah, so this work is a joint work of the individuals you see on this first slide here. And I just like to start by just doing a brief summary of the project before we get into the slides. And so the motivation is that in the past several years in the U.S., we've seen PV installs with substantial price declines, but also a large dispersion in prices, really wide range between the lowest prices and the highest prices. And since a primary policy goal here is to reduce prices, this combination of declining prices and a large price dispersion leads to our core research question, which is what factors determine whether a system is low priced? And the novelty of this paper here is the focus on low-price systems, and we're going to be calling them LP systems. And I apologize in advance for using that acronym throughout, but we'll be using it frequently, and I'll define it in a few minutes. But there's two main answers to that question of what factors determine whether a system is low price. So the first is that it's a combination. We see a combination of significant variables, including competition variables, policy variables, location matters, and system characteristics definitely matter. So that's the first answer. And then the second kind of main answer here is that we really do see some differences in looking at low-price systems compared to looking at average-price systems. And I think that's really what the contribution and kind of the distinct aspect of this project really is. So we'll get at that in a few minutes. So I'm going to go to the second slide here just to give you an outline of what I'll be talking about. I'll start with a little bit of motivation and context as an introduction. Then I'll talk about the data set, which is really, I think, what kind of underlies why this project is possible at all. Then go through some descriptive evidence, kind of looking at some overall trends, what the distribution looks like, and where things appear different across space with some maps. Then we'll look at a comparison of means, so looking at one variable at a time, which variables are different for low price versus other systems. And then we'll put the variables all together in a single model and look at them at the same time, which gives slightly different answers. And so we'll do a regression analysis of predictors of low price systems, where we're trying to understand how variables affect the likelihood of a system being low priced. And then I'll finish off with some interpretations of those results, some implications for policy as well. So that's what we'll cover in the next 25 minutes or so. Okay, so just to provide a little bit more on the context here. So we've seen these really impressive PV prices decline really impressively worldwide. We still have this wide dispersion in prices. And if we're really interested in stimulating price reductions in the future, if that's a real motivation of policy, then we should be understanding what it is about low price systems that makes them potentially different from other systems. So the questions: what characteristics are different about low price PV systems? What factors increase the likelihood of a system being LP? And then how can these conditions be reproduced to drive down US PV system prices? That's really the policy question we're trying to inform here. So what we're trying to do here is inform about future prices and with the notion that that can stimulate further market development of PV. And as Galen mentioned at the beginning, this project is part of a larger series of projects under this Academic Partners Program that really take advantage of the data that LBL has collected over several years. Okay, so that's the context and motivation. On to slide 4. So just a quick overview of the data here. So we're using LBL's Tracking the Sun data set, which is installation level. And when I say installation, that's a single, mostly a residential installation. These are collected by state incentive programs, and then Berkeley Lab pulls them together, does a fair amount of cleaning to make them comparable, and then we have a data set there. And here our focus is on what we're calling smaller PV systems. They're almost all residential, but not completely, but they're intended to represent the residential market. So we put a limit on size between 1 and 15 kilowatt DC. There are only installations installed in 2013, so our focus here is really on trying to understand the most recent trends. The most recent clean data set that is available is 2013. And this, in terms of how much it represents the entire market, this includes about 51% of the US grid-connected residential and commercial PV in 2013. In going through and cleaning the data set, we do drop some observations for a few different reasons. For example, some states don't provide county-level location information, and so we can't use those because they don't. We're not able to construct all the variables we need to. Similarly, some other states or programs don't include installer information, and that is an important set of variables we use as well. And so in a couple of minutes, I'll show you what states we have and which states we have incomplete data on. Another important qualifier here is that we do include TPO systems, third-party owned systems, but we only include them if they're not an appraised value system. So we're trying to get TPO prices that are more reliable, and we drop the ones that are appraised value. The table shows the final data sets. This is the fully cleaned data set for which we have full information on all the variables we need for our regression analysis. This is this clean set of 42,611 systems. You can see that they're grouped in such that about 5 states have more than 1,000 systems in them. Most of them are in California, and you can see the other large states at the top there. So this is kind of our important number throughout is this 42,611 installed systems. Okay, so that's the data. And now we're going to start looking at what the data say a little bit, especially with respect to LP systems. So on slide 5 here, the first thing is, what do we mean by a low-priced system? So the first thing to take is we're going to use dollars per watt installed as the price we're looking at. And we define low priced in 4 ways. So if you look at the left-hand column on the slide here, the most kind of extreme or stringent definition for low price would be just to take the lowest 5% of installed systems dollars per watt in 2013, and those are low price systems. We can expand it to the P10 or up to the 10th percentile, up to the 20th percentile, and then this 4th definition really just tries to control for 2 things. One is the size of a system, which seems to matter quite a bit, and also looking at module or component cost, module and inverter prices over time. So controlling for those 2 things, for size and for what we call hard costs, we look at which are the cheapest or the least expensive systems. We do, and you can see these 4 definitions on the figure on the right. So this is one of the most crucial figures for this study. This is just taking the 42,611 systems, and it's a histogram by installed price in dollars per watt. And then you can see the shape of the histogram is relatively symmetric, relatively normal. You can see where our main definition for low priced is that red area there. So that's the lowest 10th percentile. You can see at just at $3.09 a watt is where that 5th percentile comes in. The 20th percentile comes in at $3.92 a watt. And then that blue line there is the one in which we control for system size and for when the systems were installed. You can see that that doesn't match to a cleanly ordering of the installations by dollars per watt because we're controlling for those 2 variables there. So anyway, those are the 3 or the 4 definitions of LP here. What we do for most of this, though, is focus on the P10. It seems to have a nice compromise of having enough systems so that we can say something interesting and significant, and yet it is still, they're pretty exceptional that they're only the lowest 10%. So there's something meaningful about the results that way as well. So we do keep the other ones, and we do all the analyses on all of these definitions on 5, 10, 20, and the residuals ones. But we really focus on P10 as the main results, and then the others we consider robustness checks to make sure that we're not getting results just because of the arbitrary 10th percentile. So. Okay, so those are the definitions there. But keep this figure in mind because this is really what's distinguishing this study is we're really focusing on what separates the systems in red versus the systems to the right in the white region there. Okay, so this is all based on prices. So on the next slide here, I just want to take pause for 1 minute and talk about what we mean by these prices. So this is the reported transaction prices between the system owner and the installer. I've already mentioned that we get rid of the appraised value systems because those don't seem to fit in as cleanly in terms of this more strict definition of a transaction. What's included in the prices are these items on the left. So it's these, you might think of it as hardware on the top 4 items, and then soft costs below that. And just to be clear about what's not in here, so these systems are certainly affected, and the market for them is affected by incentives and policies and the top 3 items on the right-hand column there, but they're not included in the prices. This is pre-incentive prices, and there's no grid integration or pollution externalities included as well. So that's just what's in and what's not in these prices here. Okay, so that's slide 6. On slide 7, let's just take a look at where these low-price systems, and that's these red systems on that histogram a couple of slides ago, where they're located. So this is using the P10 definition, and the percentages here are percent low-priced by state here. And the colored states are the ones for which we have complete data and which we use in our subsequent analyses. The gray states are states where we have price data, but we are missing data such as who the installers are or where the systems within the state were installed. And so we don't have enough information to include them in our regression analysis. But we can kind of map them in comparison to the other states for which we do have. Just a comment on the percentages here. So as a benchmark, you would say if low price systems were perfectly evenly distributed across the United States, every state would have 10% as the number of systems in the state that were low priced. But you can see that they're clearly not. So we've got these darker reddish orange states which have larger proportions of the systems there are low priced. And then the lighter shaded yellowish states are underrepresented in low priced systems. And then the gray states are the ones that have been dropped. Texas is one that we had to drop that's a particularly large one. But the other colored states are large markets. Okay, so that's where the LP systems are. And we'll return to this geographic separation in our analyses that follow from here. Okay, then we'll talk about what the explanatory variables are. And this is starting to get into the analysis here. The choices of these categories here, competition, firm characteristics, market characteristics, demographics, policies, cost, size, system characteristics, and then state and time, that really is emerged from our previous work on the Academic Partners Program with some work led by Ken Gillingham that's recently been published in the Energy Journal. Is also available as a Lawrence Berkeley Lab report. So that's where we got our X variables here, and we'll be using those in the analyses that come here. But the idea here is to think about what are characteristics for which we have data that could explain the prices of systems. There's some that we don't include here, probably like most importantly maybe is roof characteristics, but we've got a broad number of variables here to explain a lot of the variation in prices that we do see. One of the most important ones, I would say, is this one on the top right of this slide here under policies, the customer value of solar. And there's a lot that goes into that particular one, so I just want to spend a couple minutes focusing on that variable. So here's the customer value of solar variable, and the idea there is that it encompasses several different components and puts them all together in a normalized way so that you get a variable that's in dollars per watt about how much all of these different components add together in terms of how much value to the consumer solar creates. And so you can see that specifically there are kind of 5 categories: tax credits, cash rebates, performance-based incentives, solar renewable energy certificate payments, and then bill savings. And then in the parentheses there is just the lowest level of aggregation for which we have the data. So for example, with tax credits, there are federal tax credits that are in here, but the state ones are the lowest level of geographic variation we have. So we'll be using that this variable quite a bit. And I thought this map that Eric made is a particularly informative one because it shows you some of the variation in the western states, but in particular in two of the biggest markets, California and Arizona, where you have high value of solar in California and a much lower value of solar in Arizona. And so we'll be looking at that comparison later on as well. Okay, so those are the variables. And now just going into the beginnings of the analysis, let's look at this one. I apologize, it's a little small. It's going to be easier to read in the report. But the idea here is to compare for each variable individually to see what it looks like for the LP systems, for the low price systems, and compare that to the non-LP systems. So for example, with our LP 10 definition, comparing the mean from the 0 to the 10th percentile compared to the mean of the 11th to the 99th percentile. So we do that for each variable. And each of the bars is one of these different definitions of LP. So that light blue is the main one we're looking at. I'd suggest that's the one to focus on. The blue one, that P10, that's our focus. The axis is set at 1 there. So if the mean of that variable for low price systems is the same as the non-low price systems, for all the more expensive systems that is, then that value will be 1. So all the bars going to the left mean that low price systems have a lower value for that variable. So for example, it should be obvious though, but the price per watt goes to the left because the price is lower for LP than for others. And similarly for the other variables here. So we talked about value of solar. So one interesting result on value of solar is that it's lower for LP than for non-LP. For third-party owned systems, on the right-hand column there in the middle, that interpretation, because that's a binary variable, is that it's less likely for low-price systems than for non-low-price systems. So if you take all these variables, take each of these variables individually, and the stars there that are a little hard to see, the asterisks, indicate whether it's significant or not at the 95% level. You can make the conclusion that LP systems are more likely to be larger, to be self-installed, have Chinese brand panels and thin film panels. They're less likely to use microinverters, batteries, tracking mechanisms, and as well as to be building integrated or installed in new construction. So that's looking at each variable one by one. The key limitation, though, is that there may be interactions here with some of these effects. And so what we really want to do is look at each of these variables at the same time. And so to do that, we need a regression model, and that's what we do in the next slide here. So on slide 11 here, the top equation is just listing the structure of a way of understanding what the predictors are of an LP system. So the dependent variable here, what we're trying to predict is whether one of these 42,000 systems is in the LP group or not in the LP group. And the predictors are this list of variables that we had a few slides ago: competition variables, firm variables, market variables, policy variables, system characteristics, and then a few other characteristics like the state and the month in which the system was installed. And so what we're setting up is a Logit model to get estimates for each of these factors, for each of these variables. How does a change in that variable affect the likelihood of a system being low priced? So that's what we'll go on to in the next slide. Is slide 12 here. Is that, there's a few different ways to make choices about which variables get included. And so our preferred specification is base specification. That's the one we'll use as the main results. We use this Logit regression model because we've got a binary dependent variable there. For competition, we use a number of installers. For firm characteristics, we use experience and market share. And then we have a subset of systems for which we have module efficiency and where the panel was manufactured. And we exclude these because that excludes about a third of the observations if we include those variables, because we're missing them for a few of them. So we don't include those in the main specification. What we do is to look for results that are consistent across many ways of running these regressions, is we do these alternative specifications. So in Model 2, we do a very similar model to the Logit, which is the Probit model, and to see if we get different results, and for the most part they're very close. In Model 3, that's an important specification that we'll come back to a little bit later, is to drop the state variables. In Model 4, we use a concentration index for how concentrated the installer sector is by county. In Model 5, we change the characteristics we use for firms, so we look at installer scale rather than experience. And then in Model 6, we drop about a third of the observations so that we can include module efficiency and where the modules were manufactured. And then finally, we do specification number 1, but then change the dependent variable. So instead of using a variable that says its low price is at the 10th percentile or less, we use the more stricter definition of the 5th percentile, and then the looser one of the 20th percentile, and then this one where we control for system size. And the key of doing all of these is to see if we get different results by these reasonably alternative ways of structuring the model on the slide before. So we do all that. We run these regressions several different ways on all these data. And slide 13 is probably the picture that summarizes it the most concisely. And then I'll also summarize it with another picture and with some words after this slide. But if you had to have one slide that encompasses all the results, it's this one, number 13 here. And there's several tables and figures of the regression results in the paper, which is available on the website that I'll mention at the end here. But take a look at this one. The emphasis here, just to be clear, is that not just looking for whether the variables are significant, but to look at how big the effects are relative to others. So it's really to get at, if we're trying to answer this question of what variables make a system likely to be low priced, this slide tries to say, well, which are the most important? And so what is on the graph here, on the x-axis here, is the change in the odds ratio. So it's the change in the likelihood of a system being low priced if we change each of these variables by one standard deviation. So that's for all the variables that are above the dashed line between module efficiency and commercial. All of those are ratio variables, so there's a range of numeric values for them. And if we shift it by one standard deviation, for example, with county level installer experience. So if you increase county level installer experience by one standard deviation, you're 30% more likely to have that installation be low price. So that's this positive effect in terms of a favorable effect on being low priced by installer experience there. And then the white circles there are a robustness check. So those are the other 5 models that we run that we show the results for. And so if you see that the white circles are pretty close to where the bar ends, that shows that the result is robust across the different specifications, which is another way to say it doesn't make a big difference for all these ways of specifying it, how the results turn out. Below that dashed line, those are different types of variables because they're all binary variables. So a system is either commercial or it's not. It's either TPO or it's not. It's either new construction or it's not. And so for those, the interpretation is if the system gets a value of that binary variable, what's the difference in the likelihood of a system being LP compared to it not having that value? So for example, with a third-party owned system, it's 18% less likely to be low priced than a customer-owned system. So that would be an interpretation for TPO. And then for the states at the bottom there, we included all the large states, more than 200 systems that have significant results, and there's 6 of them there. So the biggest effect, or yeah, the biggest state with a big effect is Arizona, which is 23 times more likely to be low priced than our base state, which is California here. So I'll interpret these results a little bit more, but that's what this size effect is trying to get at, is which results are most important. You know, I think that a clear item that jumps out are that the state effects are pretty important here. So where you install your system has a pretty big effect on whether it's going to be LP or not. And that, you know, kind of makes sense looking back at that map we looked at a few minutes ago. Okay, so that's one way of summarizing the results. The next slide, slide 14, is another way of summarizing the results. And so in this case, we took each of the groups of variables, competition, firm, market, each of the variables themselves. We looked at those differences of means. That's what we have at t-test there. Then the logit regression, and then looked at whether we get the same results in both. A plus means it's a positive effect on LP. A negative means less likely to be LP. And then if there's a dot in front of the sign, or there's just a dot, that means it was not significant. And so in terms of interpretation, you can just read down the right-hand column there, so that a system is more likely to be low-priced in a concentrated market with few installers, with more experience for commercial installations, for customer-owned systems, with a higher customer value of solar, with more of that coming from SRECs. And then going on to the right-hand side there, more likely when lower module prices, lower inverter prices for larger systems, although there's a strong diminishing returns to size. Low priced, more likely if it's not a tracking system, if it's not building integrated PV, if it's more likely with existing homes, not with batteries, self-installations with a string inverter, with less efficient modules, Chinese panels, and thin films, and also more likely if it's installed in Arizona, New Jersey, New Mexico, to get Maine or New Hampshire. So that's just another way of representing the data on the slide before, in combination with that difference of mean slides a few minutes ago. Okay, on slide 15, This is really just putting into words what I've just said on the last couple of slides, but it might be maybe a little clearer to lay it out this way. So systems are more likely to be LP with markets with fewer installers, and then with these firm characteristics, so experience matters in markets. It's commercial installations and customer-owned, not TPO. With policy, with high customer value of solar, although with some caveats that I'll talk about in just a minute, and with the SRECs, and then these system characteristics that I just mentioned, and then the states that I just mentioned as well. And then I just wanted to also mention that Nevada, Colorado, Florida, and Delaware are also significantly likely to be low priced, although there's a much smaller number of systems there, so we didn't list them on that slide before. And then California is the base state because it's the biggest state, and so we compare all of the state characteristics to California, but it's clearly the one that's much less likely to be LP than others, although there is an important California effect that I'll talk about at the end as well. Okay, so that's a summary. In terms of kind of stepping back and interpreting what some of this means, so in terms of the competition and the firm variables, that is that experience seems to lead to lower price systems. So that's consistent with the notion of learning by doing, and certainly consistent with the idea that policy might help learning by doing. That we see a high proportion of low price systems in concentrated markets, but by small firms, suggests, and I don't think we've nailed this one completely, but it just keeps coming up in our results, that some of the low price systems we're seeing are firms, small firms, entering established markets, competing with large firms, and pricing aggressively for market entry. And so something that comes out of that we'll be talking about in our future work is the issues of reputation for the installers and risk that customers might be confronting in making this large decision that homeowners might be facing here. In terms of the market and state variables, so it does seem that TPO systems are less likely to be low priced, and it could be that there's something about the standardized pricing that TPO typically tends to use. And generally what we see, if you look at the distribution of TPO system prices versus the distribution of non-TPO system prices, the TPO systems is a narrower distribution, so just less extreme, so less likely to be low priced. Strong state effects, I mentioned, California much less likely to be LP, but some other prices stronger than that. System characteristics, in terms of sizes, that's consistent with economies of scale that we know about. And the system design components are generally consistent with what we know. One that's not, is a little bit different, is this higher likelihood of low price systems for existing construction versus new construction. That's really in contrast to studies that look at the mean, which find that new construction offers quite a bit of savings. And so again, maybe this reflects some standardized pricing that new construction is using that might be lower on average than retrofit installations, but doesn't yield the most inexpensive systems. And so it's kind of in a range between the low priced and the average, where new construction may be most interesting. Okay, and then I want to have a slide on the value of solar variable itself, just because it's an important one, and potentially because it includes so many different components, requires a bit of nuance for interpretation. So we found that a higher customer value of solar, so higher dollars per watt in terms of the value of solar, is associated with a higher likelihood of low-priced systems. And that is in contrast with previous studies that our group has done, which show that higher incentives raise prices. And that's pretty consistent with theory that would say that you're basically increasing people's willingness to pay, and thus prices rise with the subsidies they're getting to some extent. Why is this? Why are we finding that it goes the opposite way from our own previous work? Well, partially it could be that we're looking at the most recent data, and so maybe that reason number one, explanation number one, is that we're looking at installations in 2013 versus our own previous work that looked at the 3 years before that. it could be that the customer value of solar is picking up the effects of some other factor. And one thing that does come up is that the effect, and you can see this on slide number 12 or 13 with the sizes, is that the effective value of solar becomes insignificant if you get rid of the state level dummies. So there could be that there's something happening at the state level that value of solar is picking up that's not exactly about the value of solar but something else at the state. So that's possible. What we're also seeing in terms of state level is that the strongest value of solar effect is in California, and particularly in Northern California. So Northern California has a high value of solar, but also a relatively high percentage of low-price systems. And that's in contrast to most of the rest of the country, where a high value of solar will make systems more expensive and generally have less low-price systems. But some reason in Northern California, high value of solar, but also a lot of inexpensive systems. So that's an interesting geographical feature that may have some explanation behind it that we're not picking up on here. And then the other issue here is that it could be that this is a real effect and we're actually getting it. And what it actually is that the customer value of solar is affecting the left tail of the price distribution, so the lowest price systems, differently than it does at the mean. So it could be that subsidies raise prices in general, but for whatever reason, they're generating a wider range of systems, a wider range of configurations, of pricing models, of business models, and that variation is leading to some very inexpensive systems. So that kind of offset the overall trend, which is that higher value of solar leads to higher prices. So there could be something that higher value solar is creating kind of opportunities for experimentation or some novel models that are resulting in some exceptionally low-priced installations. Okay, so that's on 17. So in terms of what this means for policymaking and where we're taking this next. So one thing to keep in mind is if you look at this data set over time, it's pretty clear that the low-price systems today, the extremes, the 5th or 10th percentile, if past trends continue, they'll be the mean-priced systems of the future and probably the near-term future. And so we may be just looking at the dynamics of the mainstream in a couple of years. That we have distinct determinants at the low end versus looking at the middle, at the mean, suggests that policymakers should look closely at the drivers for LP systems because they really are different. And that brings us the question of, are these drivers just exogenous good luck, or are they somehow amenable to policy intervention? So for example, our results suggest that solar subsidies might be positively influencing the generation of LP systems in some areas. And when I say generation, I'm not talking about power output. I'm talking about creating new systems that are novel in some way that make them less expensive, despite the effect of subsidies generally raising prices. So in terms of further research, and Ryan will talk more about this in a little bit, but some of the near-term ideas we have for working this and some of the things we're already doing. One is to expand the data sample to looking at systems without incentives and looking at more recent systems. So we're already looking at 2014. The other is to expand and refine the explanatory variables. At some point, it would be really helpful to control for roof type, height, angle, and that type of important factor. Looking at measures of system quality. So that's quality over time is not something we've captured so far. Potentially module efficiency might be the closest thing we have so far, but there are other ways of looking at performance, maybe for a subset of these data that would be helpful for understanding if low priced at installation also results in low priced at in terms of generation over time. And then try to understand the TPO contract pricing, because that's becoming an increasingly large and important part of the market, and focus on price dispersion as well. And so we currently have a project on that. Okay, so I've mentioned quite a few items here and have referred to this report. And so the full report, a summary fact sheet, these slides, this briefing itself and a recording of the webinar are on the link that you see on slide 19, and then the contact information for the co-authors of the study are there as well. So thanks, and I'll leave it to Ryan next.
Great. Thanks, Greg, and good morning or good afternoon to those on this webinar. I do want to just spend a couple of minutes discussing the larger series of work within which Greg's most recent and important work is housed. As Galen mentioned earlier, and as Greg also noted, this is part of a larger data analytics academic partners program run by Lawrence Berkeley National Lab. The overall objective of that program is to leverage large data sets, to this point largely the Tracking the Sun data set, though we are not precluded from using others as well, and also to leverage leading academic partners throughout the U.S. to conduct in-depth, innovative, oftentimes statistical analysis to try to address open issues in the solar market about PV price trends, but also market trends as well. We have had a number of efforts within this program over the last 3-year term, and thanks to the Department of Energy's solar program, there will be more to come over the coming 3 years as well. Our core academic partners are listed here. Obviously, you've been hearing from Greg Nemeth today, but we also have Yale University, led by Ken Gillingham, and University of Texas at Austin, led by Varun Rai, as well as a number of very capable graduate students, some of whom have moved on to the National Renewable Energy Lab and elsewhere over time. I want to say just a few words about some of the past work. So for those that are interested in this kind of work, obviously certainly welcome looking through Greg's report and paper in more detail, but there have been 3 other areas of work that I will very briefly summarize. You'll note on the bottom of each of the 3 slides that I'm about to go through is a web link that's a little bit obscured here, admittedly, but a web link that would direct you to the study, to a briefing, and to a 2-page fact sheet for each of the studies that I'll be talking about here over the next couple of minutes. First, we have spent a little bit of our attention over the last number of years trying to understand the impact of local permitting regulations and processes, as well as local regulations more generally on the price of PV, really seeking to highlight the magnitude of cost reduction or price reduction that might be possible if one were able to streamline local permitting or regulatory regimes. This work has been led by Yale University and University of Texas at Austin, 2 separate reports, both of which found that streamlined permitting and local regulatory processes could meaningfully reduce the price of smaller scale residential PV. A second aspect of our work over the last number of years has been looking at the thorny issue of incentive pass-through. As many folks on the call know, maybe all of you know, a variety of state and utility programs exist or have existed to provide rebates or other forms of incentives to residential and also commercial solar systems. But there's a question about how much of those incentives and how much of the change in those incentives over time or by geography have been passed through to the end-use customer versus being absorbed in the supply chain. And so work from the University of Texas at Austin has been focusing on this issue, emphasizing principally the California CSI program and finding a pretty high level of incentive pass-through within that program. And then third and finally, under the leadership of Ken Gillingham at Yale University, last year we completed a major effort that sought to understand pricing heterogeneity as a whole. The work that you just heard about from Greg emphasized low price systems. What are the differential characteristics of low price systems relative to higher price systems? Well, this earlier work from Ken Gillingham focused on kind of the mean system and what factors can move pricing up or down from that mean system. In the interest of time, I'm not going to say any more about this past work, but again, remind those on the call that if you are interested in it, of course you can get a hold of the authors, but also on these slides that will be made available for all of you. There are these web links at the bottom of each of those 3 slides I went through that you can go to get more information on each of those products. And again, more is coming up over the next several of years. So with that, let me turn it over to Galen, who will moderate the Q&A.
All right, thanks Ryan, and thanks to all of you who have submitted questions. So we've got about a little under 15 minutes left, so we'll get through as many of these as we can. If you have additional questions, feel free to send them in the chat window and we'll just kind of work through them in order, more or less. So I'm going to kind of read the questions and we'll let others on the presentation team field them, probably primarily Greg, I imagine. So let's see, one question here for you, Greg. And this is really kind of a question about the definition of LP and how we construct our price variable. And the question is, does LP consider just the initial installation cost or the actual levelized cost of electricity over the expected system life, as in a net present value calculation?
Yeah, so it's the first. It's the installation cost. So it does not take into account any ongoing costs, replacing inverters or maintenance costs or cleaning. It doesn't take into account any degradation that might happen or any other factors that might affect how much electricity is produced over time. So yeah, so that's an important aspect of this study, is that we're looking at installation prices, and that yeah, it would be interesting to see and get data on what affects the longer term performance. There has been some recent work done on that, especially on degradation, that I think could be an interesting next step to take some of this.
Okay, thanks. Now let's see, another question for you, Greg. It's really sort of a sequence of related questions, so you can pick off whichever of these or whichever aspects of these questions you feel like you can answer. So the questions are, what is the average income of people acquiring LP systems? Were you able to identify low-income households acquiring LP systems? And if so, do you know an approximate percentage of low-income households acquiring these systems?
Yeah, so I guess the general answer is no. I mean, we understand income in an aggregated way, which is we understand the average income of the zip code within which an installation was installed. So that gives us some information about the neighborhood, but it doesn't give us the answer to those questions, which is what is the average income of the household that installed it? How many of those are lower income? It would be interesting questions. I guess the best that the closest we could come to that is to say what percentage of installations are in the high income band, which percentage in the medium income band, and which are in the lower income band in terms of that zip code. So it's a pretty aggregate, but would be interesting to get certainly more household level data on income. Other things we've looked at are education, but also at the zip code level, and then house value, things like that are also interesting. But right now we're working with data that are at a higher level of aggregation that would allow that.
Yeah, and I just note that there have been a number of studies published over the past few years that have done kind of zip code level analyses of solar adopter income levels. And so folks that are interested, there's sort of a growing body of literature out there, though really much of that literature kind of falls along the lines that Greg was just describing, where it's really not necessarily looking at the incomes of the specific individuals that are adopting PV, but rather at the kind of demographic and income profiles of the regions where PV is being adopted.
Yep.
Let's see. One more question here, Greg. So this is on Maine, the state of Maine. And the question is really to just to cut to the chase, why does it have such a large proportion of LP installations?
Yeah, I don't know. That's the next step to take some of this is to look into a little bit beyond the variables that we have here, what explains it. I know in some of the earlier work we did, we had a pretty strong hypothesis going into it that that labor costs, that wage rates would make a really big effect, and so you might expect that some regions of Maine might have lower labor costs than the other extreme, which might be in some of the western coast locations. But we found that labor costs are not very well correlated with the price of the installed system. So I guess that's one that I would probably cross off, which might be a candidate. Other reasons, I don't know. Yeah, I think I'm interested to look at these states now that seem to be doing so well in terms of what's actually explaining it.
Yep. Okay, we have another question that may yield a similar kind of answer. And so the question is, do you have any deeper info on each of the variables on slide 10? Specifically, what causes microinverters to be undesirable for an LP system? And does that change with installation size, or is that not a significant factor?
Microinverters, so the interaction of microinverters and size, that's interesting. I don't think we ever looked at that. So the idea is that microinverters might not do well at low sizes but improve things at larger sizes, or maybe the opposite, but that there's an interaction with size. That's interesting. We haven't looked at that. What else on microinverters? Less likely to be LP. I don't know. One thing that does come up quite a bit is that there does seem to be investments in kind of higher quality panels in a lot of different ways, potentially from certain manufacturers, potentially with higher efficiencies, and I don't know, maybe microinverters goes into that, and basically people are willing to pay a premium for kind of higher, more advanced technology. But that's my experience.
And this is Ryan here. I guess I would just confirm that as well. It kind of gets back to an earlier comment about whether we're looking at just the upfront cost or really the all-in levelized cost of the system. I think everybody in the industry is well aware that microinverters are simply more expensive than string inverters on a general average basis. And so it should come as no surprise, I think, that microinverters are less commonly part of the lowest cost systems or the lowest price systems than our string inverters. But of course, those people who are installing systems with microinverters may be gaining other benefits in terms of long-run performance of their system. And so we need to be a little bit careful about extrapolating from a low upfront price system type of formulation, which is what our study focused on, and what individual customers might be focused on, which is partly the upfront price, but of course also relates to the longer term performance and operations and maintenance expenditures associated with their systems.
Okay, great. Let's see. So we've got another question here. This is a fairly basic definitional one. And this goes back to one of your early slides, Greg, on what is included in the installed price data. And the question is simply, none of the costs shown on the initial graph include the investment tax credit, so we can assume that the cost is 1/3 of that.
Right. So we don't include, yeah, you can see it on the slide there. So investment tax credit is not included here. So this is the price before you take any of the credits that are listed there. The way we did address it, though, is that that's included in the value of solar, so that we're controlling for it with that value of solar variable. So it's not in the prices, but we are addressing it.
Okay, thanks. Let's see. Got time for one or two more here. So this is just a basic question. Actually, I'll field this one. The participant asked or noted that they were surprised that there are no Hawaii systems in the data sample, and was just asking whether no systems were installed in Hawaii in 2013. And I'll take that and say that certainly there were many systems installed in Hawaii in 2013. Unfortunately, we don't have any data on systems installed in Hawaii for a number of reasons. But suffice to say, that state was excluded from our sample simply for lack of data, not for lack of actual PV systems. Let's see. I think maybe we've got one more question and one more, really more of a comment, I suppose, but worth sharing with the rest of the group. So this last question is really just asking about installer level data. The participant says that he's guessing that we may not have data regarding individual companies associated with each system, but if we do, he would be interested to know if that was a variable that was tracked. In other words, were there certain companies that wound up in the low-priced category?
Yeah, so I guess the variables, we do have the companies for most of the systems here. And some of the variables that turn out to be important are how much experience a company has in installing panels. I think we had about 1,500 or so installers in our data set here, so we weren't looking at the effects of the individual companies, but we were looking at the effects of some of the characteristics of individual companies, and one that does seem to be pretty helpful in terms of having increasing the likelihood of being low priced is a company that has more experience in installing systems.
All right. Well, thanks, Greg. So as it turns out, we are actually at the top of the hour here, and so we're going to need to call the webinar. But I would just like to thank all of you for attending and for your questions. If you have additional questions, feel free to send any of the authors an email, and we'll do our best to respond. Hopefully you were able to copy down earlier the web address where you can download the report and the presentation and other materials. If not, feel free to, again, just contact us and we can point you towards the appropriate location on the web. And so with that, I will just thank you all, and we will see you next time.